Oh, I'm lecturing and I don't know.
Well, that's crazy. Quizzes are just quizzes. They're not tests. So they don't take the whole time. Yeah, so then I got some time left over for me to do some stuff. So always quizzes, I'll lecture afterwards. So anything from homework stuff? Somebody made it into chapter 3 yet? No? It's alright, go ahead.
I want to ask you something, Frank, if you can explain it to me, because I didn't know this, and I think I still don't fully understand it. You know, on the quiz we had where you had to give the power of these to the number to 7.
So do it again? Sorry.
Okay. B is like B on the outside, and then you have to give that power to whatever. But anyway, I found out that it raises it to the second.
I think she means like distribute. Like
Yeah,
when
we
it's a B
distribute.
on the outside. And
Oh, no. So yeah, what's B times B? Is this
Yeah, I didn't know that.
But I mean, what is how do you do 7 squared? How would you work that out? I mean, what is 7 squared? What is 7 squared?
7 times 7.
Right?
Mm-hmm.
So then what's B squared?
B times B.
Okay, so you knew it. You knew it. I mean, that's what exponents are for, right? What are exponents for? So I don't have to write it, I don't have to repeat it so many times. So I know exponents means multiplication, and the number that it is tells me how many of them I'm multiplying, right? That's where all the properties of exponents come from, is from that definition. From one math person being lazy or frugal with their time, to be more nice. You know, so if I had A times A times A times A times A, oh my God. So I'm just going to say A, and then everybody goes, so what I mean by that is 6 A's multiplying, and everybody goes, okay, cool, that's all right. Right? And there's a lot of asymmetry between that and this. What would this be? Six. Hey, a number in front means that many of those adding. A number up here means that many of those multiplying. Same idea. So they're both just ways of accumulating repeats. I don't want to write A 80 times, right? So I can make it A to the 80th. Or 80A if they're adding each other. It's just a way to consolidate what I'm writing. Yeah.
this is probably a dumb question, but if you're squaring a negative, say like -2 squared would be +4, right?
Totally. So there's
Okay.
this, there's this, there's this,
Yeah.
and then there's a completely separate problem known as this. They do not have the same answer. They so desperately can't have the same answer. Because this one's going to be negative. It's a negative number. This one is squaring a negative number. Now when you square a negative real number, negative times negative is positive. And sure enough, because what does it say I have 2 of? What do I have 2 of? 2 negative 2's. Now here, what do I have 2 of? 2 2's. Because that negative is just sitting there, and I have 2 2's. So here the negatives kill each other. Here's only one negative. No other negative to kill them. So a few people are doing this in the homework. That just doesn't make sense. There's a negative in front of a number, so the answer's got to be negative. Right? That is 9. That's a true statement so far. And then what's it telling me to do? Put a negative 1. Okay? But that does not contradict me saying that when you square a negative number, you get a positive number. Because am I squaring a negative number here? No. 3 squared is positive 9. And then it says, oh yeah, put a negative on it. Yes, ma'am.
Okay. Then the next thing, and I think after this is the hardest thing, the thing I had a hard problem with. You know when you doing the like terms, you pull exponents first out of the problem.
How do you mean?
Like, they say like.
All right, let's say we got 4m squared. I think this is related to the question you were trying to ask earlier. Say I had this. All right. What do I do first? Yeah, well, here I can't do anything, right? 3 minus m is 3 minus m. So what do I do? Distribute. Two things. It's got to go to both, of course, but it's negative, right? So what's negative 4m times 3? This is still here. Negative 4m times 3. Negative 4m times negative m. Because m times m is m squared. And now what's like terms? Yeah, these guys. I got 4m squares there. Do you see any more m squares? Yeah, I got 4 more over there. So how many m squares I got? 8. I really want you to understand that I'm not just making it sound that that's what's happening. I got 4 of them there. I got 4 more of them there. I got 8 of them. Right? Do I have any more m's? Anywhere? No, I don't see any m's. I see m squares and m squares. I put those together. Any m's? No, he's by himself, poor little dude. So like terms has had the same variables and the same amount of each variable. This guy's only got 1 m. It's not the same as these guys. These are a certain number of m squares. Yes, sir.
So that would be the answer.
Yep. That's as far as you can go. You can't say you got negative 4 anythings, because you got 8 of these minus 12 of those. You can't put those together. You can't consolidate that.
So you always work left to right? Or is it always just left to right when you're working for the answer?
Well, what tells me what order to do things in?
Still following the order, right?
It never goes away. Never. So why did I just start doing left to right? Because the only operations I had were subtraction and addition. And they are on the same level. So I do them as they come. Right? So order operations never goes away. You're never in a section that doesn't need order operations ever. Because it is the under foundation of grammar of math. It's everywhere in math, everywhere. It's just how math. You can't suddenly go, well, I don't have to use English grammar no more because, the white man, black, in the road house. What are you doing? I don't understand what you're saying. So grammar and language helps us understand each other. Grammar and math helps us get to the same answer. Yeah?
Would it still be the same if there's negative 12m plus 8m squared?
Yeah, cool. 12's negative. 8's positive. This one.
How come when you do that, the exponents don't change?
Exponents are based on
How many times you're multiplying?
multiplication. So when will they change? When I multiply or divide. Coefficients are based on, what are coefficients based on? Addition. So when will they change? When I add or subtract. So why did that become an 8? Because I was adding. So I got 4 of these and 4 of these, I got 8 of these. Now if you were to put a 4 here, what I would say is, I don't see any m4s. How did you get 8 of them? I don't see any m4s. I see 8 m squares all day. I like it. And you already know this. You know this. What's 2x plus x? Not 3x squared, right? 3x. So what's 2x squared plus x squared? 3x squared. I like it. Same reason. So that's why when I add or subtract, these have to be exactly the same so I can just consolidate how many of those things I have. But when I multiply, can I multiply x squared times x? What do I get?
3 or
X to the third. So when I multiply, it just needs the base to be the same so it can consolidate how many of those I have. So it's really just a question of a lot of what we do in math with the symbols and how to rewrite things in the rules are just to write them quicker. That's all. Instead of writing 7a's, let me just write a to the 7th power if I'm multiplying them. Consolidation, that's all it is. So, if I had a times a times a times a times a times a times a, what would that be? A7, right? Is that cool? And then I go, oh shit, I had 2 more A's there. Oh shit! So it's times a squared. Oh shit, but then how many A's do I have total? 9. That's why you add powers when you multiply like bases, because you're just like, oh, I had a couple more A's. Now I got 9 A's. I don't have 14 A's. Right? There's only 9 A's up there. So it's beyond memorization. It's, do you understand why it works the way it does? No, don't just memorize something. Understand why it works that way. Then you don't have to memorize it. I only got so much room in my brain. If I memorized all the math that I know, I don't know. I couldn't. I couldn't. There's no way. So if you're really good at math, you realize, I can't memorize every damn thing in the world. If it just makes sense why it works that way, it's not memorization. All right, maybe. Okay. Anything else from anything? Maybe math related. Yes. Not from the debate last night. I don't want to talk about it. Oh, man. That was entertaining. Somebody made a point that they think Donald Trump thinks he's on a reality show. And that would actually make a lot of more sense. I don't know where you guys stand. I'm not going to get into the politics about it. Let's drop all of that. Morgan, you got a question on math?
Section 2.4, when it says write each ray as a unit ray, what does that mean?
Where are we at, sir? 2.4, number?
Say 25.
25.
I just want to know how.
Oh, so it really just means reduce. It means make the bottom 1. So if I said I went 90 miles in 3 hours, well, how many miles per hour was I going? You just divide. You just get it to become over 1. So that's a unit rate.
Oh.
So if I have price per 1 ounce, that's a unit price. Right? Still a unit rate, but we call it in that case as unit cost or unit price. Is that cool? Just make the bottom 1. Okay. Anything else from homework or just something that's been bugging you for a while about math?
5522.
Did I get him going? Yeah. Let's see. 55 looks gross. Let me ask you what seems like an unrelated question. How many total terms do you see in that equation? Like there's one term right there, right? How many total terms are there? 4. 1, 2, 3, 4. Right? I need to make each of them have what? What do I do when there's fractions in an equation? How can I kill them? Yes. And the thing that people do is they forget this dude. So there's 4 terms. I got to make all of them have the same LCD so that I can then do the next step, which is to kill that denominator. So what's underneath him already? 1. All right. So now what's the LCD going to be? 10. So now you just make everybody have that. So what are you going to multiply him by?
2.
Top and bottom, 2. 10. So now you have 6x over 10 minus 10x over 10 equals x over 10 minus 25 over 10. And now you just do what to both sides?
Multiply by 10.
Multiply by 10. Everything's being divided by 10. That's what's making everything look gross. So I'm going to undo that. I'm going to say, screw that. Let me multiply by 10. Because now, bam, 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 bam. Some guys might realize, once you get all the bottoms the same, you can basically just cross them all out. Because you are going to multiply by that. So now what am I left with?
6x minus.
What would you tell the person that put 60 here? They put a 60 here. Why do you think they did that? Yeah, they multiplied the 10. What would you tell them? You're crazy. What would you tell them? If I put a 60 here and they're like, man, I got the wrong answer, what am I... What would you tell them? There is why they get 60? Oh, crap. Because 10 times 6 is 60, right? But what would you tell them about that 10? Is it still there? No, it died. You don't have to say it like that. It died. So, all right, 6x minus 10x equals x minus 25. Now that should be easy. Actually, should just be easy to solve that now. Comes out to a nice number. Okay, cool. I like it. Anything else from anything at all? Mathematically related? Okay. Okay. So last time we started talking about graphing points. I want to talk a little bit about functions because I started talking about that a bit. We're going to get into graphing equations possibly a little bit today, but definitely on Tuesday. So two things. If I had a function what would be an example of something that's not a function? How could I draw something that's not a function? What would I have to make happen for it to not be a function?
Repeated x's.
Yeah, it's got to fail the vertical line test. So what that really means, if you want to say it in English, is it's got to kind of come back on itself. It's got to come back on itself like that, right? So that would try to be saying that, if I said at 3 seconds, where was the thing? And you say it's here, here, and here. And I'm like, holy, what? So that's why it's called the vertical line test. If there's a vertical line that goes through this more than once, anywhere, it's not a function. It doesn't represent something physical, moving like that. All right, maybe. So I like it. The definition of function is for every x, there can be only one y. There can only be one output. Okay, cool. I like it. So a function would be something like, let me be much more specific here. I like it. Woo-ha! Let's make another point there. Yeah. So is that a function? Yes, there's no vertical line that goes through more than once. So I would say that's a function. This could be, I wouldn't want to be on this plane. This could be a plane. Oh yeah, wow! We all basically died there. Now, to go a little bit beyond that. So this is a function check. Passes the vertical line test. Check. Let me put some scale on here for us. Can somebody tell me what's the output when the input is negative 1?
Right?
Don't go that high. What happens? When the input is negative 1, what's the output?
0.
Say again?
What is it? Oh,
No. So I don't know if you can't. What's 1, 2, 3? Is that where?
3.
Yeah. Okay. So I don't go that high. So here's the input in negative 1, right? Input's like the question I ask at negative 1. What's the output? So the output must have been 3, because that's where the point is, right? It goes through the point negative 1, 3. So for an input in negative 1, the output is 3. I like it. Can somebody tell me what are all the inputs that I'm allowed to use? What inputs am I allowed to use? Can I use the input of 4? So what do I mean by this? Why am I allowed to use the input of 1? Because 1 actually has a point associated with it, doesn't it? Does 4 have a point associated with it? No. So what's the smallest input that has a point associated with it? 3. Negative 3. And what's the biggest input? 3. So remember, inputs are x's. Now later in math we would learn that there could be t for time. It doesn't have to be x, but it's that axis. And we're going to call that the x-axis for right now. Inputs are x's, and we call this the domain. The domain is all the inputs I'm allowed to use. All the inputs that actually have outputs. So the domain for this one would be from negative 3 to 3. The range is the same idea, except it's for the outputs. So let me just ask you, what would the range be? What's the range of this? This one you almost can't go wrong. What's the lowest output that it has? Negative 3. And what's the highest output that it has?
3.
So it just happens to have the same, right? So the range here would be from negative 3 to 3. So the domain is just all the inputs that I'm allowed to use. And the range is all the outputs that I see. That's all those are. Have you guys ever heard those words before, domain and range? Some of you guys? Domain is all the x's I'm allowed to use, all the inputs. Range is all the y's that come out. Yes, sir.
So it doesn't matter where the point is. I mean, we don't have point on negative 3. So
How do you mean? Which negative 3? Right there.
Yeah, you don't have
Right
point
there.
there. Oh.
So what are the outputs? Do I have an output of negative 2.5? Yes, I do, right there. For about 2.9, the output is negative 2.5. You see that? So what I sometimes tell people, just go with this. Find the domain, you have a little dude walking on the x-axis. Little dude walking, right? Little dude walking. And the first time he sees the graph is at negative 3. And he's looking up and down. He sees the graph all the way until 3. After that, he doesn't see it anymore. So, oh, I'm all alone again. Shit. And then if you walk on the y-axis, what's the first time, looking left and right, what's the first time he sees the graph? Negative 3. And he sees it all the way through until he gets to 3. That's the range. That's a nice other kind of way to say that. I like that little dude walking. Not Christopher walking. I can't do Christopher walking. Just some little dude walking. More cowbell. No, I can't do it. All right. So that's one little thing, domain and range. And the next thing is kind of huge. I wish I knew why this gives people so much trouble, but let me give it to you this way first and try to get you to understand it's the same damn thing. If I said evaluate x squared minus x for x equal to 2, could you do that? I would hope so. Take a minute, do it. Don't say anything. what'd you guys get? So if x is 2, what do you do with that? Plug it in, right? If x is 2, then I can rewrite this as x squared minus x. But x is 2, I just put a 2 in place, right? So what do you get? 4 minus 2? 2. I like it. That was scary. You playing like that. Y'all camouflage today and making noises. Scaring everybody. Alright. So here's the thing I told you was coming. This is what's called function notation. And all it is, well, one basic thing about it, we use it in a lot of different ways. But one basic thing about it is it uses substitution to do things. So I could say this function, I can call it f of x. So what I'm saying is, the f function, what does it do to x? It squares it and then subtracts its value, right? So this is kind of like a rule for what f does to something. And one reason we do this is now I can have a g function that's totally different. I can have an h function that's totally different. So then it's easy to tell which thing to use when. So we'll do another problem like that here in a minute. But now watch. This does not mean f times x. This is read as f of x. So if I said, what's the square root of 9? Does that mean square root symbol times 9? That doesn't make any damn sense. Could I divide by the square root symbol? Yay! Can I divide by the square root symbol? No, of course not, right? So you can't divide by f, you can't do it. This is one thing, f of x. What does f do to x? It does this. So what would this be then? Same thing. So really, what is this saying to you? It says, what do you get when you put a 2 into f? That's the exact same thing that this asks you to do, right? Evaluate the function f for an input of 2. That's what that says. So function notation at its most basic level is just substitution. It says, here is the function, and then it can ask you, okay, now plug a 2 in. All right, I'll plug a 2 in, and do exactly what we did up here. That's 2 squared minus 2, which is 2. So f of 2 is 2. Now think about this. If I graph this weird looking little dude, what point would it go through? Input of 2, output of. So it would go through the point 2, 2. I like it. So another reason that we do this is so I can see the inputs and I can see the output. All in one line, I can see them both. So I can see what point this thing goes through. Okay, so let's do another one. Give you some, let's say that g of x is x over 4 minus 2. And let's say that h of x is 5 minus x cubed. Yeah, baby. So then what would, let's see, what would g of negative 8? Just remind yourself that, now which function are you going to use? The top one or the bottom? Top one, because I said g, not h, right? So number one, that's one reason why we even created function notation, so I can quickly tell what the hell to do with this number in here. I'm going to use this top one. And then what am I going to do with that number then? What do I do with that negative 8 then? Just substitute. Yeah, please let that be not that bad. It's just a quicker way. Look how I had to write, look at all these words, man. I don't like all those words. I want to be able to say all that with just bam. So this means evaluate the function x over 4 minus 2 for a value of negative. That's a lot of freaking words. I just want to be able to say that very quickly. So g of negative 8, I just plug a negative 8 in. And then you get what? Yeah, negative 2 minus 2, negative 4. So g of negative 8 equals negative 4. So what point does that function go through if I were to graph it? Negative 8, comma, negative 4. I love it. For an x input of negative 8, the output is negative 4. I love it. Kick ass. So here, let's see. What would h of, which got Jeff 2, and try h of w. Yeah. Do you have a question or
Oh.
hold on to it, Morgan? Hold on to it.
Answer.
Alright, so for both of these, you're using the top of the bottom.